Hi everyone, long time no see. Today I'm going to be working on an iPhone 7 Plus that was sent here for no power. I have chosen this iPhone 7 Plus for one reason and one reason only. This iPhone 7 Plus was actually sent here because it is not boot looping. That's right, we have an iPhone 7 Plus that is not boot looping. Let's have a look at this thing. I'm going to show you where I'm at. I have hooked a DC power supply to it, and whenever I hooked the DC power supply to it, our current consumption was right at 3 amps or whatever. It maxed out my supply, so that tells me that we have a short on a main power line. So I'm going to go ahead. Where is my little screw thingy? There's my screw thingy. Got to get myself a new tri-wing driver. This thing is a heaping pile of cow manure, and not like an anorexic Florida cow either. It's a heaping pile of cow manure like a Missouri cow. Things are still in horrible disarray here. I mean, it's been a lot more than I expected to pick up and make such a large move. As many hours and as much time as I put into planning, you can never really see some of these things. There's been a lot of unexpected pitfalls that I could have never ever seen coming. So before I tear this thing apart, I'm going to go ahead and show you what it is that I did that brought me to choosing this one for a video. We're going to connect our DC power here, and I'm going to push the power button on the power supply, watching current consumption very closely. As soon as I push the button, it draws 3.2 amps, which means we have a short on a main power line. So back over to my hands here, we're going to remove the power supply, and then we are going to remove the logic board from this thing. It's a lot harder to do this in front of a camera. It really is. Let's go ahead and remove this antenna looking thing. Dun, 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 dun. If you've got an iPhone 7 that's not coming on, or it won't finish its power up, this video is most likely not for you. Most of them are all like, oh, this one's boot looping. Okay, why is this one boot looping? Because they seem to boot loop for pretty much everything. Okay, is that all our Phillips screws? It is, so we're going to switch over and we're going to use our standoff driver here. There we go. Guess it's time for me to buy a different driver. We're down here. This one actually doesn't look pre-mutilated. Watch me find a main short, and then after I get that fixed, then that's when we'll discover our baseband, our chronic baseband illness. Now, even though this is a VCC main short, or a VDD main, or maybe boost, yeah, not boost, but even though this is a main short, I'm still going to check our baseband. One of our main baseband lines that likes to screw up on almost all of them. There we go. Okay. And ooh, got the SIM card in it. Next, what I'm going to do, I'm going to open up an iPhone 7 PCB board view file here, and to decide which one to open up, the easiest way is to just flip it over and read the number off the bottom. 820-00249-A. And on here we have 820. What? Oh, it's a 7 Plus. 249-A. Okay, so here's the board, and we're going to zoom in, and we're going to pick out our very most top power rail here, and here is VDD main. I'm going to check VDD main for a short to ground. For that, I'm going to use continuity mode. We're going to be taking our measurement in ohms. I'm going to put my black probe on ground, and I'm going to put my red probe on VDD main, and we're most likely going to get a short. It is reading 0.7. So we get 0.7 ohms to ground. In order to narrow down this short as quickly and efficiently as possible, what I'm going to do is I'm going to take my black probe here, and I'm going to hook it in on this side of my Sigilant power supply, and I'm going to hook my red probe over here onto this side of my Sigilant power supply. I'm going to connect our ground to the board, like that. I'm going to set the power supply up here. I'm going to change my first channel here. I'm going to switch this over to 4 volts. And I'm going to change our amperage to as high as it'll go. Now, before I do this, I want to say that if you get a reading in ohms that isn't like a straight short, let's say you check it and you get 30 ohms of resistance. If that's the case, it may not be it may not be a good idea just to pour a straight 4 volts to it, especially on prior repair attempts, because what I run into is that sometimes you will wind up somewhere where some low voltage line is connected to a higher voltage line. Let's say you've got a GPU line hooked up to VCC main by somebody that's worked on this board, and there's a short under an IC somewhere, or whatever. You've got a 1 volt, 1.1 volt or some line hooked up to a 4 volt line, and you check for resistance and you get 30 ohms. Well, 30 ohms, you know, I know this isn't going to make sense if somebody doesn't understand electricity and ohms and the way Ohm's law works, but if you get like a 30 ohm reading, it may not be a bad idea when you're doing this to start out at 1 volt, 2 volts, and sort of work your way up and try to find it with as little voltage as possible. Me looking at this board and seeing that we've got a 0 ohm short, this is going to be a cap somewhere. So in order to find that the most efficient way possible, I'm going to switch my power supply onto 4 volts, 3.2 amps. I'm going to hit the parallel button, which is going to give me, basically hook my 2 channels in parallel, and it's going to give me 4 volts at 6.4 amps is going to be my maximum output here. So like I said, efficient. I'm trying to do this fast. So we're going to turn the supply on. And we are now putting out 4 volts, and we're drawing 0.1 amp from each channel. And I'm going to take my VCC main probe here, my anode, my positive lead here, and I'm going to touch this little cap out here. And I've got my hand laid across the board, and I'm trying to figure out which end of the board heats up. It jumps straight to 6.4 amps. Okay. This is going to be really hard for me to record. I guess you could watch my hands maybe. Can you see my hands? If I turn the light down on the microscope? No, then I can't see. Oh no, I can't see! That's good. Okay. So I'm going to put 6 amps of current. Okay, I think it's going to be right here under my finger. One day, I promise you, I'm going to invest in an infrared camera. I know there's been at least a couple hundred of you that said, why don't you buy an infrared camera? And I spent a good deal of time in the past thinking that it would just be a waste of money and I would always use alcohol and stuff. Wait, I'm on the wrong... This is the wrong sticker. But now that I've seen the different modes and the way that these things can actually work, I no longer believe it's a waste of money. And if I could do my tool purchase from last year over again, I would be including a thermal camera. So maybe this year, probably toward the end of this year, I'm going to be making another tool purchase. You didn't see me tear that sticker. And a thermal camera is pretty high up on my list. So before I pour the coals to this again, let's have a look under the microscope. Let's see, by this point we might be able to visibly see something frying. Okay, I don't see any discolored caps. But I believe I'll be able to get my finger straight on it, which means I should be able to get burnt real nice and good here. So let's see. Back over to screen capture. Let's look at the bottom of the board. What are our other candidates here for VDD main? We've got a bunch of them. We're going to jump right out here to C5809RF. And actually, let's go ahead. I'm going to freeze this board. Yeah, let's go ahead and use freeze spray. That'll make this easier. A lot faster. Freeze spray. Look at me holding the can upside down. You know this is air duster. And you know it's got that stupid detergent agent in here. I'll have some official freeze spray soon. This stuff is disgusting. For all of you that said, why don't you just use air duster? This is why. Because it's nasty. Oh, and I didn't check. Am I on the right board? Just on PMU-RF, so it's over here. I didn't check to see if we had any known baseband shorts. It's a good idea to do that first, because we might wind up finding this VDD main short and then come up with a phone that only boot loops. Okay, we're freezing over nice and frosty. Well, I don't know about nice and frosty, but we're freezing over a little bit, by God. And I'm failing miserably. I didn't even come close to seeing where that was. Okay, no luck in that spot. So I'm going to go ahead, I'm going to blow off all my condensation. Let's scroll down just a little bit lower on the board. See a thermal camera and I would have had this solved already. Okay, so we do have a considerable amount of caps here. I'm so excited to be working on an iPhone 7 that's not boot looping. Oh, what a klutz. Can't believe I just tore the sticker. Again. I just edit out all the places where I tore the sticker. Actually, watch should actually be on the other side of the board. Alright. let's go back to the old-fashioned way and try to feel for heat. This is 12 watts of power. I mean, we should start to feel something. Okay, let's have a closer look. I don't know if it's maybe the humidity here, but my freeze spray does not seem to be behaving exactly the same. It seems a bit different. Okay, so let's use alcohol. I'm going to put alcohol up here around this thing. I know there's going to be 30 people who say, you should just get a Fleur can. Alright. Okay. We're going to look for alcohol to bubble. I think I see it. Watch up here. I think up here is going to be where it's at. This is going to be a really long, boring video, guys. That's okay. I've got big time plans for my YouTube channel. But geez, it took us a long time to get back up and running here. I am excited to say we are up and running at full force. This cap right here, C2301. Let's watch that cap once more. Okay. Right there at my fingertip. Wait a minute. Watch right here. Watch right here when I apply current to this. Let's do this once more. You gotta see what I'm seeing. This is gonna be the first time I've found a short by spatter. Let's put our alcohol here, okay? Let's add our current. And watch this thing spatter alcohol on the bench. See that right there? Does the audio codec have VCC main hook to it? Audio codec seems to be what's getting hot. How about right on the other side? Yeah, we've got this row of caps here, which are directly on the other side of the PCB from this audio codec. So, our temperature source suggests that we have a short under the shield. That's what it suggests. And I'm going to cut right here. Across the sticker. Okay. And we're going to start warming this up. We're going to remove the shield. I think our short's going to be right under the shield. Okay. I think I can already see the cap without a microscope. Alright, so let's zoom on in. I'm going to put you under the microscope. We're going to have a look and see what cap this is. Oh boy, look at that one. We have just been baking the total holy snot out of that thing. Look at that cap. Alright, so back over to screen capture. What's the value on that cap? We could just... Whoa. Can I control Z that crap? No. We could just... I grabbed a hold of the wrong... I tried to move the window on the capture software instead of the actual software. So we could just remove that cap and move on. That might actually be what I do. Let's have a look here. C3532. I'm going to put a little bit of flux on there. I'm going to use these tweezers that have the horrible tips on them. And we're going to grab a hold of that cap and get rid of it. Hey, honey. Can I help you? Thank you. Very nice. Thank you, honey.
The lady I talked to at the vitamin shop?
Yeah?
Bernie lives in O'Fallon.
Wow.
The odds, right?
No kidding.
Always meeting those people that have family back in Missouri, too. She has a niece in O'Fallon and a niece in Little Rock, Arkansas.
Alright, who am I kidding? We're going to go ahead and stick this cap back on here. Why? Because it's easy and I've already tinned the pads. Alright, so we're going to stick this little cap down in here. That's a good little cap. There we go. That's back on there. If you're wondering what I replaced that with, a brand spanking new 10 microfarad 6.3 volt capacitor. So let's get a little bit of alcohol on this. We're going to clean this up. Yeah, if you're working on an iPhone 7 and you're planning on fixing it, chances are that you're not going to be doing this to fix it, because they are notorious for other problems. I mean, yeah, they got VCC or VDD main shorts and standard shorted caps too, but most of the time iPhone 7 comes in for service. It has nothing to do with capacitors. Alright, since I am infinitely confident that that is a fix on this one, I'm going to go ahead and lay our PCB back up here. I'm going to lay the shield. Are we in view? Sort of. I'm going to lay the shield back on it. And we're going to start warming this up. I haven't put hundreds or thousands of these shields back on yet, as I have on the 6 through 6S's. Because typically if I have a problem under the shield, it's going out the door as a no fix. Baseband fault. Oh, come on. Line up. Okay, we'll take that. Oh, this is miserable. What's going on? Don't watch this. I'm going to do a video on how to not put the shield back on an iPhone 7 Plus. There we go. If you do it slow enough, you can do it without crinkling up the sticker. Okay. The next thing I'm going to do here is I'm going to go ahead, I'm going to put our stickers back on the bottom. And I'm doing that now because the board is really hot, and I want to move on to my next repair. Being that the board is hot, that's what I need for these bottom stickers to stick right back on. Okay. We're going to go ahead and use our customer screen assembly here. Now I bet you the behavior here is similar in a sense that the battery was directly shorted to ground, which the batteries, they have protection built into them, which basically is a circuit breaker. It kills the power. So I bet you when we connect a charger to this, we get a very brief battery charging icon, pick up tools, followed by boot. Because the battery's not actually dead, it's had a circuit breaker tripped. So what we're going to do here, we're going to connect a charger to USB. The charger says 60 milliamps. 90, there we go, 900 milliamps, and then Apple logo booting. So we're going to let this phone boot up. See if I can throw the 720 on the screen there so you can see it as well. Hopefully I don't have to edit this video, because it showed something that I didn't want the customer to see. Alright, we're up to passcode screen. It did not come with a passcode. I might have it in the computer. However, since this thing booted up so quickly like this, I'm really confident that this thing is going to be solved. We do have a working home button, and this phone is likely going to be good to go. So I've got a little bit of reassembly to do here, and then of course I'm going to check it top to bottom to make sure baseband's okay, make sure it detects a SIM card, and make sure this phone is live and well. So this is going to be the first video that I post from my new habitat. A lot of stuff has happened between the last time I posted a video and I'm posting now, but I am thrilled to say that we are back up and running full speed, and everybody's happy and everything is well. I have a lot more to say about our trip and our move and a lot of things that I've recorded, but I'm going to be saving that for a future video. So guys, that is it for this video, and I hope you all have successful repairs, and I will see you soon. Thanks for watching. Have a good day.